Woo! Woo! We're live. Okay. We got a lot going on today because etcd's totally doesn't. Matt's here. Matt, you want to introduce yourself?
Yeah, hey everybody.
Going on today because etcd's totally doesn't. Matt's here. What? Matt, you want to introduce yourself? Where's all the feedback coming from?
Someone is listening the same video. It's Matt.
Oh, it's. Oh, I think Matt, you've got feedback. Well, while Matt fits his feedback, we'll just get started. So, all right, everybody knows who Ricardo is. So, I just created a cluster with Tanzu, and so if I do Tanzu cluster list, we could see it's in here. And then if I do Tanzu, and what we're gonna do is we're gonna tmux new dash s antrea live. So we're gonna go over a couple of different things today. So we're gonna Tanzu cluster list, and I'm gonna Tanzu cluster kube config get antrea live. I'm gonna grab this one, and then we're gonna. Oh God, Ricardo. Here we go. Okay, now I'm gonna go in here. Right? Oh, God. Okay, here we go. Okay, kubectx. All right, so I'm in here. Now, if I do kubectl get nodes dash show wide. Okay, so I've got 3 control planes and 3 masters, right? And so these 3 control planes. Oh, hey, Matt. Oh, it looks like Matt's back. Okay.
Hey, sorry about that.
I think testing better. Yeah, I think it's better now, Matt. Okay. Now I've got these 3 nodes. So what we're going to do today is I want to play around a little bit with, I want to look at that etcd thing, right? Because etcd was, did you, Ricardo, did you hear about this etcd bug that came out last week?
I was watching you discussing about that, but I didn't actually saw what's going on. So show us.
All right. Okay. So what happened? I'll show you what happened. All right. So let me remove this, and then let me add my screen. And then we're going to do some KPNG stuff, and we're going to look at some nginx stuff. So we're going to do like lightning round today. Okay. So let me share my dang screen here. All right, there we go. Cool. So here we go. All right, so somebody's adding Jepsen. That was 7 hours ago. Someone's excited about that. 11 hours ago, another. Wow. Okay, so they're already finding bugs. So there was a big emergency. It was such a big emergency that on Google Groups, they announced that etcd groups.google.com. Let me see if I can pull it up. Etcd groups. Yeah, here it is. So Danielle Lancashire, who works on the kubelet, she told us about this at over at VMware. She was monitoring this mailing list, and she let us know that with the recent reproduction of data inconsistencies in 13766, okay, so that's this issue here, okay, so that's this guy, right? etcd maintainers no longer recommending 3.5 for production, okay, so that's a pretty big deal because the version of etcd that Kubernetes was recommended to use for 1.22 was etcd 3.5, right? So if you go to Kubernetes GitHub and if you go to the build, there's a thing in here. It's like build, and then if you go into build, you've got this dependencies etcd. So you see this? You see that, Ricardo? It's not recommended for production 3.5.1. So you can go in here and you can look, right? So somebody needs to do something about that. Anyway, so obviously everybody's working on this. So 3.5.3, this problem affects 3.5.0.1.2. Okay, so everybody in the whole world everybody flipped out and was like, oh God, we can't. Everybody's doing stuff about this. OpenShift is doing stuff. VMware is doing stuff. We're all trying to figure out what we do now that we're all shipping this version of etcd that has this data corruption issue. So the way that corruption issue manifests itself is described in this bug. So I think this is it. Was this it? Yeah, I think this is it. Yeah. So then I think this is Benjamin. He's got this great repo where he just goes and he describes exactly what happens with these issues. So in here so here he actually describes it. So so if you take this endpoint, what ultimately happens if you get a different revision? Okay, so you get a different revision depending on the node you're on. So you get an inconsistency, which is real weird because the whole point of etcd is that it's supposed to be consistent. You get a different revision of a key. So if I'm reading from node 1, if I'm on node 1 and I have etcd member 1 and I read a key from that node, I'll get one value. But then if I'm reading from a different node in my cluster, from a different etcd node in my cluster, I will get a different value. But those two etcd nodes think that they're synchronized, but they're not. So one of them loses sync. And the reason it loses sync is because there's this in-memory cache that is not which is real confusing to me. Like I always thought the whole point of etcd is everything's written to disk before anybody can write anything. But there's some weird corner case where the in-memory cache that sort of like locks and then writes something is like, there's a way you can violate that. Like if you like hard reboot a machine, like if you sig kill the machine. So if you it's like you sig kill etcd and reboot the machine, and you do some special weird dance or something, then in that one specific situation, you can actually an etcd node could actually think that it's in sync, but actually have old revisions of a key that were being written. So this issue here, I should put this in the notes, right? So let me go to our hackmd, antrea live notes. So let me put it in the notes, and then we'll just very quickly look. Here it is. So this is the issue that describes it. And then, so here's the way that you can sort of play with this and sort of check for it on your own clusters. You can run this endpoint status cluster, and then I always like to run this check perf, and then you can see how fast things sort of reconcile. So I want to try to run those two now. Like I've run these before. I want to try to run these on a cluster really quickly just to show you all, and then we can like jump. So so if I do, so I'm in here, and then I'm going to I'm going to SSH cap v at. So I'm going to SSH into one of.
Dumb question. You're running this inside your nodes, is that right?
Yeah, you run it. Yeah, exactly. Okay. You run it inside the nodes. Now, I filed an issue upstream, which is, I think this would be a really cool thing for somebody to do if they wanted to, is like, we should build a test. I think it would be really cool if we actually built a soak Kubernetes test issues. Maybe I can find it. Yeah, let me find it. So I filed an issue, Matt, and that issue was here. I don't know, but maybe they won't let me do it. I don't know. It's kind of a weird test idea, but I think we should have a disruptive test, which actually does something like creates a daemon set, and then I don't know what the daemon set would do, like continuously write to etcd, like go crazy doing a ton of writes, and then maybe somehow reproduce this by like continually adding, like updating an annotation, and then continually like reading that annotation from a daemon set that's on a whole bunch of different nodes, so that if there's some chance that if one node is reading from a different etcd replica than a different node, which would likely be the case in a cluster API scenario, but because at least in Tanzu, we have an etcd on every node and it's separate. And every API server talks to the local etcd. It doesn't talk through like a load balanced etcd. I don't know if, so anyways, but if you had some way to, you could simulate this if you had a whole bunch of daemon sets, I think, just writing to an etcd, and maybe you were doing somehow, you could get fancy and maybe you could have one of those daemon sets like killing the node or rebooting the node, hard rebooting the node while it was running, because you can do that. And we do have upstream tests that do reboots through using a mechanism like that. So, but yes, so I think there's things that you could do. I think there's cool stuff you could do that, like in cluster stuff, that would be a useful way to sort of diagnose and reproduce this. But like we don't have anything like that yet. We don't have a test. So one way you can sort of try, like, see what the state of your cluster is, you could run this. So if you run this command, so I'm SSH'd into a node, and I don't have etcd, so I have to find sudo su find // etcd ctl. Oh, that's weird. Find / sorry. So this is a really weird thing that I do on these. These are Tanzu clusters, and we happen to have etcd ctl. This is really a dumb thing to do, but it works. So you can alias etcd ctl equals this file that happens to live in this container, because I'm on a cluster that's running etcd in a container.
Wait,
and then,
I cannot see what you are writing.
Oh, wait. Hold on. Let me add myself. Thank you, Ricardo. Okay. Here we go. So I can do this. I can alias that, and then I can now run this command. So if I go etcd-ctl, and on Tanzu clusters we run etcd locally, and then I can run this, and then I could say endpoint status - cluster, right? And so that will give me a quick. Okay. So that's just going to give me the status of, like, the endpoints. And then I can do, what's it called? I think it's output is table. If I do, I can do, I'll show you. Hold on. It's table. I think it's like -- output. Let me Google it. Hold on. If I do endpoint status, etcd endpoint status. Okay. So if I do, etcd-ctl point status. Write out -- table. Okay. Okay, so in this case, I have, this is because it's a one node cluster. So Tanzu cluster, Tanzu. Okay. But this should be a multi-node cluster. kubectl get nodes -o wide. That should be maybe. Yeah, there it is, cluster. There it is. Okay. So you have to do -- cluster. Oh, that's weird. If you just do -cluster, it oh no, I don't know. That's really weird. Okay, cool. It works. Okay, so if I do this now, what I get, right? When I run this, what I get now is I get the IDs of all the etcd members, right? Because I have 3 control plane nodes. So I have the IDs of all the members, and you can see this is etcd 3.5.0. And the database size is the exact same. It's 15 megabytes. And the raft index is 1044. Now, watch this, right? So now what I could do is I can what do? I do SSH capv at, now I can go in here, and now what if so if I do this, if I jump into one of these nodes, and then I could do the same alias, right? I could do the same alias, right? Now I'm in a different node, and then I can run another command, and this is one of my favorite etcd commands to test a cluster to see if it's broken. Now you can't do this in GKE, okay? So you can't do this in GKE because GKE doesn't and I probably EKS and Azure you can't do it also because they don't expose etcd to you. In fact, I don't even know if GKE uses etcd because they don't give you access to the control plane. You can't see the API server or any of that stuff anymore. So now what I can do is I can run this, and what this is going to do is it's going to put a ton of load on etcd. Oh, damn it. Okay, so here we go. So now I'm going to run this command. And then I'm going to run this command, right? And this is going to put a bunch of load on etcd, and I'm going to rerun that same command. Okay. And as this is running, I'm going to see, like, does the raft index, see how it's starting? See, look at that. You see that? So, like, you could see that the raft index, like, there's like a sort of temporary blip in time where the index is diverged a little bit, right, on one of these nodes. But you could see two of them are like kind of always in sync, right? And now they're all in sync again because we're putting a ton of load up here on the etcd server. So because we're putting so much load, the index of raft, which is the database underlying the consensus algorithm that underlies etcd, is like temporarily diverging on one of those, So it's like, okay, but it pretty quickly gets back in sync, as you can see, and then eventually everything sort of comes back to where it was. And presumably, if you're trying to read something, like, this doesn't normally cause any problems, right? Or like, it's not supposed to. But in a large cluster, what people have found is that, like, if in etcd 3.5.0 and .1 and .2, like, if you do like a hard reboot of a node or something during one of these sort of time periods where a lot of writes are coming in, you actually may get a permanent divergence of that, of those raft values. And then etcd will diverge. And then after you reboot the node, it'll actually never catch back up. It won't even know that it needs to catch up because it'll think that it's completely converged. And then the way you know that is I think the way most people were discovering that in production is they would see that the database sizes were drifting. I believe. And anyway, so that issue can show you more of the details of that. So, but we got a lot that we're going to go do it today. So Ricardo has some nginx stuff, and we're also going to start talking. We're also going to do like a introduction to like how to get involved in KPNG. So, what do we want to do first? Ricardo, do you want to talk about nginx, or do you want me to do a quick KPNG thing, or what?
Up to you. I can show something right now, and then we can jump into KPNG, or you can start. That's up to you. You are the boss.
Yeah,
Jay.
show us your nginx jails thing. I think that'll be interesting.
Okay. So, do you allow me to share my screen? Let me see here if this is not gonna block or something. Screen 1. No, that's a screen 2. Cool.
There you go. Where is it?
Yeah.
Yeah, I got it. Okay.
Yeah. Cool. So, well, we've been working on Ingress nginx. As you folks have seen, we've been fighting the good fight of like CVE security incidents versus how to improve security in the Ingress. And the thing is that Ingress, opposite to a lot of other things in Kubernetes, it's actually exposed to the internet, right? And sometimes it's the first thing that users they have access. So thinking in the security risk of this thing, actually, it's something exposed that gets a lot of access to your Kubernetes cluster, right? Because you need a service account and other things to configure that proxy. And that might actually it's targeted it's targeted because it's like probably the best way into compromising a cluster from the outside. And we've been working on some CVEs and other things that have appeared in Ingress, right?
Hi, Mathilde. Sorry, I just wanted to say hi to Mathilde.
Yeah, no problem. Say hi to everyone.
Scott's here. Hi, Scott. And Junjin's here. And a meme. And Scott's asking if etcd's broken. Yeah, Scott showed me some tricks, but Scott, that machine health check thing didn't work. Anyways, whatever. Keep going, Ricardo.
Yeah, no problem. So one thing that's problematic actually today in Ingress nginx, if you take a look into this diagram here above, this one, just this part here, right? and it's not appearing the thing there. But anyway, this one here. Let me put the color on background or something like that with. Okay. Come on. Yeah, it hates me. Anyway. Oh, sorry. Okay, this thing. So this blue thing here, and one thing that actually we figured out is that we needed a way to split the nginx and the controller from the same container, right? So what happens right now is that the external user they call an nginx proxy server, and the same nginx is running on the same place of the controller, which is actually responsible to get Kubernetes configurations using a service account, and then write the template for this nginx, right? So writing the configuration for this thing. So let's take a look into the problem, the real problem, right? So I do have two nginx running here, right? I know that Matt loves every time that I say nginx, so I'm gonna keep saying nginx until Matt it's happy with nginx. Yeah,
I appreciate it. Thank you.
yeah. So one of them is running on a ch root, while the other one it's not, right? And I just don't remember. Okay, so the left one is running as a ch root, and the right one no. And we do have those two here running. So let's take a look first into the one which is called just nginx here, right? And it's spec.
So you chrooted the good nginx. Jesus. So that is what you chrooted one of them and you didn't chroot the other.
Yeah. Because right now this is actually the base container for Ingress nginx, right? So I jailed one.
I don't see anything. What are you doing? Are you in a terminal somewhere?
Yeah. Why isn't shared? Because I'm sharing my screen. Hold on. Let me try sharing again. Share screen. Screen 2. Why isn't getting... Okay, I'm gonna share. Is it appearing? Or is it just blank?
Let's see. What do we got? I don't see... No, I don't see you.
Weird. Let me try opening this in another browser, Jay. Hold on.
Okay.
I will be back in...
So while you do this, I'll do a 5-minute how to get started with KPNG, and then we'll come back to you, okay?
Okay, sounds good.
All right, so let me take over while you do this. Okay, so I'm going to be back here. So, Matt, this is a good time to just... If you have any KPNG questions, you can ask them. Otherwise, I'm just going to do a really quick walkthrough of the code base and how to get started.
Cool.
Okay, so Matt and me were talking about KPNG and how to get involved in it and so on and so forth. And unlike most projects, I mean, I guess everything in Kubernetes is like this nowadays. But I mean, it's there's just a lot to get started, and so I think one of the things that I think is kind of the most important thing is to kind of decide if you even want to do it. And because anybody that wants to get involved, it's a long road, and it's definitely worth it. But I think of it, the way I think of the code base is real simple. There's this server directory, and then there's these backends directory, right? And the backends directory is where all the logic is for the different types of kube proxies that you have. So if you go to backends, right, there's a directory for IP tables, IPVSs, NFT, and Windows. So each one of those implement a backend for KPNG, right? So, and the way the backends work is, if I go to KPNG, you can see the overall architecture of it here, right? The way the backends work is, oh, damn it. What did I do? Oh, God. Here it is. Okay, so the way it works, yeah. So if you go in here, this is your sort of, each one of these backends is KPNG Miro. I have a Miro board that's even better. Each one of these backends is down here. And so there's a thing that talks to the API server and intercepts what the API server has inside of it, endpoints and services. And then after that, it reads all that stuff, and then it puts it into the KPNG data model, which is like a highly simplified data model that just makes sense for Kubernetes, where it's like, hierarchical, a single YAML, right? Where you have service endpoint, service endpoint. And then that really sort of optimized data model that describes the networking state space of Kubernetes is then sent down periodically through this to the backends. And then the backends then go act on that. So what this does right now, the way the kube proxy works is that there's all these watches, and the watches watch the API server directly. And so that has scalability limitations. It also makes it very hard to understand what the backends do because they're sort of coupled to the Kubernetes data model, or to the Kubernetes sort of like API semantics. Whereas actually what the backends have to do is actually quite simple. They just have to, every time there's a service, they have to write an IP tables rule to forward that service to an endpoint. So KPNG sort of decouples the complexity of the Kubernetes API and aggregating endpoints and services and all the rest of that from the sort of wrappery code that you need to do to like build IP tables rules that do routing and so on and so forth. As folks know, there's there's 4 implementations here, which is, those of you that run Kubernetes know this, like most of you run IP tables as your proxy. Folks are running Cilium will maybe be running Cilium proxy or Antrea proxy if you're running Antrea. But then there's IPVS, there's NFT, and then there's Windows. Windows has a kernel space and a user space. So each one of these backends has its own code. And then if you go into like one of the backends, like I've got the Windows proxy open over here. And like what I've been doing on the Windows side is I've been sort of implementing a function where I'm trying to like build a wrapper to store HNS IDs because KPNG does not have Windows specific logic and in its data model yet. So like what I'm doing in here is sort of implementing the Windows kernel space proxier to cache HNS, sort of, which are the Windows specific sort of equivalent to like the so they're essentially like Windows data model objects that correspond to a new load balancing or like a new pod endpoint, and so that needs to be codified because it hasn't been like codified yet in KPNG because it was built for Linux, and the data model because of that doesn't have this concept of an HNS endpoint. So in implementing the kernel space backend, I'm just sort of trying to figure out a way to like sort of, once we make the call to Windows to get an HNS ID so we can have an endpoint to load balance traffic to, add something that'll sort of like somehow maybe encode that and add it to the KPNG native object. And I know I'm going really fast here. So, but anyways, that's just like one example of the type of thing you might need to do for a backend. But like in order to get started, it's pretty easy. You can just go to cd ... and you can run hack. And I think you did some of this and you can hack kaping local up, but even easier is there's these tests you can run. So like you can run E2E, you can run the like make test, you can run the test commands, and the test commands will give you the ability to, let's see here, if I do like hack test cd hack, and if I do like test e2e e2e.sh, right? If I run any of these, right? Test e2e.sh, right? If I run any of these, like there's the user space Linux one, right? Hack test user space lin, right? So I can like run this, right? And like this will do, oh, oops, I'm not in the, I think I just do this. Oh, okay. So if I just do like test IPv4 IP tables, right? So if we do this, then it will literally run, it'll compile and run all the KPNG tests for IP tables. And then some of them will fail and some of them will succeed. And you can just like dig in and start seeing the ones that fail or succeed. But chances are you'll need a buddy to do this because the first time you do it, it's really complicated. And we've been doing this for 6 months, and we've learned all this stuff and asked questions to people like Antonio and Mikhail and all these other people. So you just sort of have to learn it by doing it with someone the first time. So you'd have to find one of these, and then like for IP tables, the way you would solve any problems you run into is you do Docker PS, and then you Docker exec into one of the nodes, right? -t-i, into like one of these nodes, and then you might like, if you had a failing test or something, you'd run IP tables save, and you'd look at what Kubernetes endpoints had been written, and then you'd go back and compare them, and so on and so forth. So that's like a really quick introduction. Like now we can get back to Ricardo's thing, or if you have any questions, Matt, we can. Oh. Scott, where's supervisor ESXi? Wait, did everybody drop? I think everybody somehow got dropped from the stream, and I have no idea how.
You kicked us.
Did I kick everybody out? Okay.
You kicked us just to keep talking about Kaping. So we are gonna make a T-shirt of Kaping to you. Okay. You are our Kaping leader. Yeah.
I don't know how that happened. That's really weird. So, anyways, that was a really quick introduction to the code base. I know that doesn't. You probably knew most of that, but anyways, any questions, and then we jump over to Ricardo's. Matt, you're on mute if you have any questions.
I think my questions are maybe a little bit too big.
Okay.
I gotta get a little bit hands-on with this stuff,
Okay.
and then I'll have more good questions for you.
That's totally fine. Yeah. So there's a start, and then we can just like pair on stuff. So we pair on Fridays in the community meetings, and then Matt's my neighbor here in Massachusetts, so I might like go to his house and hang out with him and do some of the stuff. Okay. Ricardo, go ahead, man. What do you want to do? What do you got?
Can you add my screen again?
Is this
Thank
it?
you.
La la la?
Yeah.
Okay.
Yeah, la. Yeah, this one.
Okay, back to nginx.
Cool.
nginx.
All right.
Okay,
So you were asking me about like left side and right side. So left side is running a CH rooted nginx, and the right side is running the former ingress nginx container before we actually started doing this container inside a container, right?
Yeah.
So if you take a look into the configuration file, it's the same on both sides, right? So I have this one here, which actually I do have a location here called come on, hold on, Jay, called / la la la, which has an alias and an auto index here, right? So this is not the end. Actually, you shouldn't be allowed actually to do that in Kubernetes ingress, right? So you shouldn't be allowed to do that, but due to some
What's an auto index? I don't know what that is, Ricardo.
I'm
I don't
show
work
you.
at nginx Labs or whatever they are.
I'm gonna show you. The thing is that this configuration you shouldn't be supposed to add, right? You shouldn't be allowed to add this configuration. Instead,
Okay.
it should be just like some configurations that you create an ingress object, and those ingress objects turns into servers and locations and backends here, right? So you asked what's this auto index thing, right? So when you call, as an example, let's say this is /3, and you call this thing, and you are pointing to some directory that doesn't have anything, it's just gonna return you like a not found, right? Or even if you have something which is not like an index.html, it's gonna return you just a not found here. You're not gonna get like a list of the files that exist inside that thing, right? So auto index actually, when you add this, it generates the list of files of that directory. So instead of getting like a 404, getting like a not found or something like that, you are gonna get the index. The index of that directory, right?
Mm-hmm.
So I have created this just to show you how it works. So imagine that
You could do this with any ingress in general, right?
Yeah, I think it's just a matter of configuration. Like you can even do it like with Apache and with web servers, right? With proxies that are also web servers. So you cannot do that with HA proxy as an example, or Contour Envoy because they are proxy servers and not web servers.
You could do it with Avi though, because Avi is a web server.
So you probably can do that with Avi. Yeah.
Okay.
So
I don't know if the Avi people are here today, but yeah. Anyways, all right, go ahead.
yeah, no problem. So imagine that you were able actually to inject this configuration in your ingress, right? So you have this ingress called jside.something.com, and you were able to add this. So somehow you were able to escape your locations and add this thing, right? So now if I come here and call this / lalala, I'm gonna see the whole file system of my container. Right? So I'm seeing not only the binaries, but I can see as an example, etc swd, right? So what's the biggest problem here actually is not just exposing all of those directories, but probably as you folks know, Kubernetes exposes inside /var/run a service account when you and this is the default behavior unless you say to Kubernetes not to mount the service account, right? And the service account is a JWT token that contains permissions to do whatever you add in the role-based access control, right?
Okay.
So if you get access to the service account of the ingress container, what happens is that actually you got access to a lot of things inside your Kubernetes cluster, right? So you can manipulate, as an example, secrets. And manipulating secrets, you can create, you can extract like certificates, or you can create a new token for you, or something like that in another namespace. You can manipulate ingress objects. Manipulating ingress objects, you can point to another user. You can expose another user ingress in a multi-tenant environment, right? So so this is why actually having this scenario here, this first one is bad, right? Because I do have the controller and nginx running on a place that they can share the volume here. So what we started to do is actually, okay, we should take the same approach of Contour as an example, like splitting this, right? So adding something here in the middle and saying, adding something here in the middle and saying, okay, this is like split. So you have in this side controller and you have in this side nginx, and they should speak with each other. Like nginx should use gRPC or something like that to get the configurations. But this is hard to do, right? This is not some easy. So the same approach that you are taking in KPNG, as an example, we should start splitting the controller and all of the backends, nginx backends. So if you connect here, you're not going to actually be able to extract information other than the things that are exposed by the controller to you. So instead of doing this right now, because this is like a midterm, you know, Jay, how much time is taking KPNG, right? And how much effort it takes to configure all of those things and to code all of those things, right?
Sure.
And Ingress Nginx also needs some more developers on it. Like we do have a bunch of folks working on a bunch of things, but we need some more people taking a look into that, right? So what we started to think is, what if I can just jail my process here? There is something inside Linux Linux kernel which is called a namespace, right? Which is actually the base for all of the containers. So when you create a container, you are creating a process namespace and you are creating a network namespace and on all of the other sort of namespace stuff, right?
Yeah.
So if I can inside my own container create a new namespace and isolate this thing and isolate nginx inside here, actually I could expose the port. The port is going to be exposed because I'm not jailing the network namespace. I'm just jailing the file system and the process. So if someone is able to extract things, it's not going to be able to extract, as an example, service accounts, right? So, or other things. So right now, got it?
Oh, that's cool.
So
it's like a more nuanced version of a container.
yeah, that's an
It's like a container that understands that the world is not just black and white. It's not just like container or no container.
Yeah, that's a container inside a container.
It's like half a container.
Yeah, that's right. That's a half a container running inside a container. That's right. Yeah. So we did have this on past, like FreeBSD does have this since a long time ago, right? Which was called jails. And Solaris got zones. Open Solaris got zones. So Docker is nothing more than like creating namespaces or jails inside like the Linux, using Linux kernel features to do that, right? So right now, if you take a look into this right side here, so let's take a look into both of sides. So if I do something like this, you are gonna see that in nginx here is actually okay. If I'm gonna just do this thing because it's gonna be, so you're gonna see that this is a binary here, right? But in this case, what we did was actually, what if I create a directory here which is called chroot. I put everything that nginx needs to run and just nginx inside the chroot, and then I jail it. So I say to nginx process, whatever you need to do, you are gonna do containerizing inside this place, right? So take a look into this. So this is how the nginx in this side is called, right? So we copy resolve.conf and then we say, okay, unshare, which is the command line when you want to create a new namespace. It can be a network namespace or a
Why do
process
they call it
namespace.
unshare?
Because you are unsharing the process that you have with like you are
From the
creating
root.
some from the root network, from the root namespaces. Yes, that's correct. Right?
You should call it like. It's just a stupid name. Okay, go on.
Cool.
See,
So
you say I'm always pissed off. Like, this is why I get mad. Like, why I get mad at things like this. I get mad at dumb names that don't make sense, Ricardo. Okay, keep going.
All right. So right now I'm running this, and what's doing is actually calling unshare, and inside this chroot thing, it's calling nginx with everything that I pass as an argument.
Got it. Okay.
So let's take a look into the other container, which is the chroot one. So if I do something like this, it still works, right? But as you can see, the size, it's much smaller than what I could see here.
Wait, did you unshare it already?
Yeah, this is unshared. This is unshared. But all of those directories, they are required to make, because I am sort of creating a new, let me just close the things here. Nginx process needs things to run, right? So it needs like a glibc library. It needs some other shared libraries.
Yeah, so you got to mount all those shared libraries in from user lib and all that.
Yeah, exactly. So I need actually to copy them. I cannot even link. I need to copy them to inside the chroot because because it's not possible from inside that unshare to access something outside, right? Even a link, a symbolic link or something like that. So I need to copy them to inside. Got it? So I sort of duplicate a bit the size of things, right?
Yeah.
So I do have right now, and this is still works. So if I do something like this, I can.
I'm going to shamelessly self-promote my book here because we have a chapter called "Let's Build a Pod," and if folks want to do, if folks want to see exactly how to do this and why you would do it, we have a whole chapter about how to build a container from scratch in there. Anyways, yeah.
Yeah. So
buy my book.
So I why don't you write them like to people that attend this meeting?
I
just make
only
a giveaway
because this
for
is
us.
really this is a good reason to buy that book. Okay. Keep going, Ricardo. Keep going. Keep going. Buy my book. Keep going.
Okay. So I still do have like things inside this container, right? But this is a much smaller this is, oh, okay, I close it on this side. Let me just start this again. I just reduced the amount of things that I do have inside here, right? So I still can access the file system of this one, and I can see everything here, even the nginx controller stuff and all of the things that it needs to run. So I would have something like var run something that right now I don't have because I'm not running inside Kubernetes, right?
Yeah.
But in this one, I won't. This even doesn't exist because I don't need it. I don't need the /var run here, right? So this is just chrooted. So let's take a look into how it looks like inside it, right? So if we go here, in this side, in the right side, let me clean the screen and improve a bit my size, the size of my font.
I don't remember this, but there's some stupid commands that you can run that don't need any shared libraries. There's just not very many.
Yeah, you can. Yeah, there are some of them, and you can also compile them in a static manner,
You
right?
could also statically compile them, yeah.
Yeah. But then the binary is gonna be like huge.
Yeah, and it's funny because like when I first did this, I was surprised that like I think like commands like ls and stuff, like there's a lot of basic commands that you're used to running that actually require libraries. I never really thought about that.
Yeah. So
I
let's
thought
say-
everything that all the basic stuff. Exactly. See. Oh wait, that actually worked.
Yeah, they need libmuscle here as an example,
Yeah,
right?
yeah.
That's the glibc from Alpine.
Yeah. Yeah.
So-
Everybody needs glibc.
Yeah. So, but in Nginx, it's a good example.
Scott has a
So let's-
question. How large did this make the nginx image? Oh,
It grown by I mean, let me think. It's something like 30 megabytes more or something like that. It's not like small, but it's not something huge as well, right? But anyway, the majority of size of Nginx image, the controller actually is not Nginx, it's mod security. So we are actually
what?
with mod security. You know, the
Mod
one
security.
for web application firewall. So we are actually going to split this thing and make mod security like another container that just mounts anything that you need inside the volumes of Nginx, of the Ingress controller container. So if you don't need mod security anymore, you don't need like a huge container with 200 megabytes or something like that. So
Oh, so
you
it's going
ask
to be a
him-
separate process,
it's going to be a separate. Actually, it's going to be a separate container.
like a sidecar.
Yeah,
Oh.
yeah,
Wow.
correct. Just with the libraries that you need. So if you need something, it's gonna mount. It's gonna do a shared volume.
Oh, cool. Okay.
So in this side, we can see that there are like a bunch of libraries that you asked, Jay. So I need to copy all of them to inside the chroot, right? So if I come here to chroot and I look into usr lib something like that, they are all here as well, right? And so this is why actually the container gains a bit more of size. And then looking at here, so as you can see, when I do the curl into that chrooted container, I'm not seeing the whole file system that's here, the same thing that I would see here, right? So you can see that both of them, they are the same. The only difference is that I do have the chroot here and the thing that Nginx needs to run inside here. And then when I call it from this side, from this container, I'm just gonna see those directories. So another thing that I don't have here is as an example, any binary. So if someone can, as an example, Nginx, let's say Nginx gets like a remote code execution vulnerability, right? So you can send well formatted strings and run like ls or do something like that. You are not gonna be able to call bin something because you don't have bin anything, right? So this is you do have all of those things, but because they are required by Nginx anyway, right? But the main ones, you are not gonna get a shell, you are not gonna get cat, you are not gonna get BusyBox or anything like that, or CP or any other things, right?
Yeah.
So yeah, so mostly this is what we've been working on, right? So at least while we are not splitting the control plane and data plane, we wanted at least to say, okay, the users will have a jail here, and inside this jail in Nginx and like a volume that it's just a slice of the root volume, but this process is just gonna be that slice and nothing else. So it's not gonna be able to escape from here.
Okay.
Right. So that's
Okay.
I think that's
That's
it,
a
Jay.
cool.
Yeah.
This is really a cool idea. Like this is an interesting thing. Like for situations where you have a container, but you want the container itself is like big and does multiple things, and you want to like sort of put an extra granular level of security on parts of that container, but not all of it. Like that's a general use case. That's a general problem. I bet Matt has that problem at work. right?
Yeah,
Like,
for sure. But then when you start customizing stuff like that, isn't it just creating more possibilities to get mixed up and apply the wrong, the wrong things to the wrong parts?
Yeah, yeah. This is something that may happen. Yeah. So this is why we've been like, as an example, nginx cannot log into a standard output, right? So it can log to var log, it can and it can log like to syslog, but it cannot log to standard output. So how can you actually get like the access logs from that shared container, right? Because it's not going to be streamed here, as you can see. Like,
oh, because you can't access standard out.
yeah. So in this case here, if I do var log
What do you need to?
Dynamics,
Why?
it's this one
Well,
is
why
this,
can't it access standard out?
it cannot. It cannot
Because
access standard out. And standard out
by design, because you want to prevent it from.
No. nginx doesn't support streaming the logs to standard output. So you need to do a symbolic link to standard output. But because I'm jailed here, I don't have the device of standard output here, right? So
Can you just mount it like you mounted everything else?
no, because then I would need like a privileged container.
Oh, you need a privileged container to mount standard output because it's a device on the host.
Yeah.
Shit.
Yeah. So yeah. So
Oh, that's weird. Okay.
one thing that we needed actually to do was to change the ingress controller, and we added inside the ingress controller that actually streams the output to standard output a syslog server, right? So a really tiny syslog server that's a Go library. So right now what happens is that nginx just send to localhost on a specific port the logs, and then I am again streaming the access logs and the error logs, but I did needed to make that pipe. So yeah, you start adding some complexity on those things, right? I mean, there is that how they say, like, there is that balance between security, performance, and usability, right? So as much as you need or you improve security, sometimes you just lose a bit of like performance, or sometimes you just lose a bit of like usability.
Every time you make stuff secure, it doesn't work anymore.
Sorry?
Anytime you make things secure, it just stops working.
Yeah. In this case, we try to make things secure, a bit more secure without breaking things, right? But still, we are like allowing users to use like the ch rooted container or the non-ch rooted for the next version, instead of just saying to them, okay, this is the only way that we are going, because we need feedback from them. So we cannot force everybody to just use the new version, the new way of nginx control.
Are you going to collect feedback? Are you going to give them a poll, Ricardo?
No, I'm just gonna watch if people start complaining or not. That's the best feedback. If someone starts complaining on Twitter or something like that, I know that something is messed up.
Feedback is a 4-letter word.
Yeah. So so as I said, so here I can see, let's say I'm gonna do this thing, and I can see all of the process here, right? And in this case, if I do, let me copy this to chroot cmp, and then, come on.
Okay.
Okay, sorry. Yeah. So I need to.
This is really cool. I just have never like you're just expanding my mind right now. Like I've never thought about doing this before.
Yeah, that's
This
cool,
is
right?
such a weird. Is there a word for this? What you're doing? Like, is there any products that do this, or are there people that do this, or is this like a pattern that people are?
I don't know.
Who came up with this idea? Is this your idea?
Yeah.
This is a cool idea, Ricardo.
But yeah, but I mean, this is.
Wait, Scott said something. Maybe he did. I tag my container images with oldest, and always have to tell people to pull the oldest images. New images are secure, and they don't work. Exactly. Says somebody agrees with me.
I can't even see my my process here, right? Because I am unshared, right? So this is.
I love the oldest nginx image because it still has a bin sh terminal and the new ones don't. And so I like memorized the nginx tag, the last one that they had that had a damn shell in it, and I still run that to this day. I have that memorized. I went through every nginx tag. I went through every single one of them until I found the one with the shell. Then I hard-coded that into my smoke test things that I do.
Cool. So you know why I can see actually the processes here?
Okay,
Do you
yeah.
have any-
Why is that?
I don't have. Sorry. First, I need to copy ls as well. But the thing is that anyone have some guess on that?
For a free T-shirt, you mean?
Yeah, maybe.
Okay, T-shirt question for the week. Can anybody guess why it is? What was the question, Ricardo?
Why I cannot see any process here
Why can't Ricardo see
inside
any
the jail?
processes? And I can answer that question, but I'm not going to answer it unless somebody else has a chance to answer it first. 5. Nobody's going to answer it. Okay, so
Okay.
it's because the process names, you're in a different process namespace.
Nope. It's because /proc is not mounted.
Oh. Well, my answer also would have been right, though.
Yeah.
There's
I
no
mean-
reason why I would have known. Okay,
don't
so you
mount-
didn't mount proc. All right.
I don't need it. Yeah. Actually,
That's
to
cool.
mount it, I would need like a privileged container or some more privileges, because there is those capabilities in Linux kernel, right? So I need the capability admin to do that, and
So
they are right now splitting the Linux capabilities. So you may be able, as an example, to mount /proc without using the capability admin.
But
or
why is
something
there a
like
/proc at all then if you didn't mount it?
that. Because I added when I was mounting the container while I was trying to create the standard output, and I forgot to remove.
Why did you even have a what? Okay, so you secretly, when we weren't looking, made a /proc directory that had nothing in it, and then you asked us a loaded question about why you couldn't see it that could have two possible answers, but nobody would have known that it was one of those two answers unless they knew that
because
you
I'm-
secretly made a directory for no reason. That
Exactly,
happens
because-
to match.
Because I don't want to give anyone a T-shirt. That's what's happened.
That was the it's
Right, and
Easter,
so-
man. It's Easter, and you're being mean to everybody.
Yeah, sorry. It's our Easter now almost as well.
Can't
It starts on
even
Friday.
be nice to us on Easter.
Yeah. I'm not paid to be nice with you, Jay. All right, so
I mean,
I
Matt's
think
here.
that-
I figured you'd be on your at least a little nicer than you normally are.
Yeah, I should be nice with Matt, not with you. So this is actually I think the thing that I wanted to show you how we are actually solving at least one of the problems of running everything together, right?
NCP
So-
Cheroots, Scott. How? What? I mean, it runs on. Does NCP run as a process on an ESXi host? I don't even know where it runs.
I'm not sure yet. Also,
Go ahead, finish what you were saying, Ricardo.
no, I was just saying thank you. That's all.
Okay, this is great. This is really cool, man. I've never thought about a problem like this or how you would solve it. So you blew my mind today. So if folks want to pair up on some Kaping stuff, reach out to me or Matt. We're both in the Upstream SIG network room quite often. And if folks want to learn more about the etcd thing, join the Google groups, mailing list for etcd, or reach out in Upstream Kubernetes as well there. We didn't have much Antrea content this week because there's so much other crazy stuff going on. We wanted to just kind of have a Geongen says, I think it's NSX Node agent that does the cheroot, and Scott says in TKGI. On OCP anywhere else you want and I think it is NSX node agent does cheroot, an agent of NCP on every K8s node. Okay, cool.
And,
So,
and
Okay,
if someone want to
NCP
join,
in the agent, it cheroots. Why would it cheroot if it's already? Oh, I guess it's the same thing. Okay, sorry. What's that, Ricardo?
no, I was just gonna say that if someone wants to join me on nginx as well, just ping me on 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 Kubernetes Slack as well. I'm around there.
Yeah.
Like if someone wanna help on this, yeah.
Yeah, folks want to help with ingress maintenance on the nginx side. Ricardo's kind of holding that whole show up with a few other people, and they always need help. So reach out to them. Okay. All right. Bye, everybody. It's 5:00 and the party's over. And we'll hang out again soon. Thanks, Matt, for coming by, and Ricardo.
Sure. Nice seeing you guys.
Thanks, everybody. Thanks, June, Jen, Scott, Mathilde. It's good to see you, Mathilde. Look, Mathilde came and said hi at the very beginning of the show. Okay, everybody came and showed up today. Okay, see y'all.
See ya. Have a nice holidays.